Have you ever wondered what exactly happens behind the scenes when you just tap your phone to pay for a coffee? Or, when you enroll in university classes online? The interfaces we interact with every day look incredibly sleek and simple, but beneath the surface, there is a massive, unseen software architecture powering the whole shebang. Today, we're diving into this explainer to pull back the curtain on enterprise integration. And trust me, by the time we finish, you are going to look at every single digital transaction in a completely different way.
So here's our roadmap for the journey today. We're starting with Beyond the Monolith, moving into the SOA revolution, then decoding SOAP and WSDL, exploring the enterprise stronghold, and finally wrapping up with the API showdown.
All right, part 1, Beyond the Monolith.
To really grasp modern system integration, we kind of have to travel back a bit and establish a baseline of how software engineering traditionally worked, long before the cloud was everywhere. Enter the monolith. And honestly, it is exactly what it sounds like. It's this traditional architecture where literally everything, your user interface, your business logic, your database access, is just tightly woven together into a single indivisible unit. When you're first building an app, this is super straightforward, right? You write the code, connect the database, hit run, and you're good. But as that system grows, this giant block of interconnected code becomes a massive bottleneck. If you want to push an update to just one tiny payment feature, you risk bringing down the entire application. It's a logistical nightmare.
The real problem with a monolith is that scaling it independently is just notoriously difficult. It's basically a giant boulder. The solution to this was service-oriented architecture, or SOA. Instead of that one massive boulder, the architecture is deliberately broken down into specialized, loosely coupled services. Think of it more like a bucket of building blocks. You can update, scale, and manage each block completely independently without knocking over the rest of the tower.
That brings us to part 2, the SOA revolution. You have to remember, system integration used to be a terrifying engineering problem. How do you get entirely different systems built by different teams in totally different programming languages to actually talk to each other? Well, this is where the concept of connecting heterogeneous applications comes into play. SOA's absolute superpower is bridging completely different systems. Take a university's infrastructure, for example. You've got a learning management system handling the coursework and a totally separate student information system handling grades and enrollment. They are fundamentally different beasts under the hood. But thanks to SOA, they can seamlessly exchange data as if they were literally made for each other.
Getting to this loosely coupled integration usually involves 3 logical steps. Step 1, you break down that old clunky monolith. Step 2, you build out those independent specialized services. And step 3, this is absolutely crucial, you connect them via network protocols. So instead of hardwiring the code together, these independent services are just sending messages back and forth over a network.
Which leads right into part 3. Decoding SOAP and WSDL.
So how exactly are they communicating over that network? We need to look at the heavy-duty protocols making this possible. Let me introduce you to SOAP, the Simple Object Access Protocol. Now, a lot of people think SOAP is some dead, forgotten tech. Actually, scratch that. It is very much alive and is a mission-critical, highly standardized messaging protocol today. It doesn't just casually send data around. No, it demands that data be exchanged using incredibly structured XML information. It enforces its rules with absolute authority.
And you can't really talk about SOAP without bringing up WSDL, which stands for Web Services Description Language. In the industry, it's often called the ultimate API contract. And that hits the nail on the head. A WSDL file isn't just a piece of casual documentation. It is an ironclad legal document for your code. 2 foreign systems absolutely must sign and agree to this exact contract before they are permitted to exchange a single byte of data. It defines the exact structure of the requests and the responses. Let's look at how this sequence actually plays out because it's fascinatingly rigid. When 2 heterogeneous systems need to talk, first, they inspect that WSDL contract. Second, the client formats a strictly validated XML request. Third, the server securely processes that request via the SOAP protocol. And finally, it fires back a similarly strict XML response. There is literally zero room for error or casual data formatting here. It is precise, it's uncompromising, and it works.
Let's move to part 4, the enterprise stronghold. So that begs the question, who actually needs this level of strict, uncompromising protocol today? Well, startups might love moving fast and breaking things, but the foundational pillars of our society, they require a bit more gravitas. If we look at heavy-duty implementations, SOAP is still the undisputed king. We are talking about global banking networks, major government agencies, massive financial transaction hubs, and high-security legacy systems. These sectors absolutely demand the rigid security, the built-in error handling, and the exactness that SOAP and XML provide. They are the unseen backbone of the modern enterprise world.
To anchor this in the real world, let's look at a modern mobile payment app like GCash over in the Philippines. Now, on the front end, it feels incredibly modern, snappy, and fast. But when that app actually needs to securely transfer your funds or verify your identity, it has to communicate with massive legacy banking infrastructures. And more often than not, those highly secure legacy backend bridges are built exactly on these rigid, heavily contracted SOA protocols.
Finally, Part 5, the API Showdown.
So how does this legacy heavyweight stack up against the modern alternatives? It's a fascinating split. Look at SOAP. It's a strict protocol. It relies entirely on XML, and it's built for enterprise and banking. Then next to it, we have REST. REST isn't a protocol, it's an architectural style. It's super flexible, it handles JSON, XML, even CSV, and it's the gold standard for modern web and mobile apps. And finally, we have GraphQL, which is essentially a query language primarily using JSON, tailored specifically for really complex data fetching on the front end.
Let's just do a quick side-by-side of the two biggest players here, REST versus SOAP. It is a classic contrast. REST is lightweight, it's stateless, meaning it doesn't need to remember your previous interactions to process a brand new request, and it's resource-based. It interacts with specific data objects, like a user profile, and it's designed around basic, fast operations, creating, reading, updating, deleting. SOAP, on the flip side, is heavyweight, relies on those strict WSDL contracts we talked about, and its main focus is high security and exact data formats.
So, what's the big takeaway from all this? The modern integration landscape is not about one single protocol winning and destroying all the others. It's about software engineers choosing the exact right architectural tool for a specific problem. You're going to use REST when you need to build standard endpoints fast. You'll pull in GraphQL when your front end needs extreme flexibility to query data. And for sure, you rely on SOAP when you're signing a strict contract with an enterprise banking system.
We have covered a lot of ground today, from the rigid blocks of monolithic software through the SOA revolution into the strict contracts of WSDL, and finally across the varied toolkit of modern APIs. So I want to leave you with this thought. The next time you tap your phone to transfer money or check your grades online, take just a second and ask yourself, is a legacy monolith, a lightweight REST API, or a highly secure SOAP contract making that happen behind the scenes? That unseen digital infrastructure is literally everywhere once you know how to look for it. Thanks for joining me on this explainer. Keep learning and keep questioning the systems around you.